story. Thank you so much for sticking me till the end. As I've been introduced, my name is Sarah Mulligan. I'm a reproductive scientist and I work in Beacon Care Fertility in Dublin. So what is a reproductive scientist? We're clinical scientists. We're specialised in reproductive medicine. So what we do, why do we want to use AI to improve IVF outcomes? So what I'm really going to focus on is one procedure in particular in IVF. So it's an embryo transfer. So that's when we're picking what embryo goes back into the uterus and what has the best chance of becoming a baby. So why do we want to do this? So it is really one of the most important decisions that we make in the IVF lab. What embryo goes back and how do we minimise negative outcomes. So Care Fertility are the largest provider of IVF across the UK, and they've been providing fertility treatment in the UK for over 25 years, helping patients to build their families. We're a growing organisation. We have 18 clinics across the UK and Ireland, with over 4 and then another 4 in the US and Spain. Most importantly, we've had over 60,000 care babies born to date. So Beacon Care Fertility is partially owned by the Beacon Medical Group and Care Fertility. And we're located at the Beacon Hospital in Dublin. We've been providing fertility care in Dublin since 2012. We're really at the forefront of fertility care in Ireland, and we really hone in on innovation and a really advanced range of treatment. And we're actually one of the leading providers of reproductive genetics in Ireland as well. So I'm really proud to work with this wonderful team. So my role is an embryologist, and I work with consultants, doctors, and other patient administrators. However, my role as an embryologist is mainly behind the scenes in an IVF lab. So sometimes we meet patients, but we're mainly found in the lab looking down the microscope. So it's really meticulous work and requires a lot of attention to detail, but it really is really, really rewarding. And when we get sent baby pictures from patients, it makes it all the hard work worthwhile. So we handle all procedures involving eggs, sperm, and embryos across all procedures. So from collecting the eggs to fertilizing them, to helping them grow in the lab, to transferring them back into the uterus. So although it can be really challenging, it is rewarding. And I feel really, really privileged to be able to witness the beginning of life in my typical workday. And I love the mix of science, technology, and then the human connection that comes with it. And making a difference in our patients' lives through my work makes me feel really fulfilled. So fertility care is really needed. The prevalence of fertility is on the rise. And sadly, fertility affects so many couples and individuals globally. Approximately 1 in 6 heterosexual couples in Ireland will face difficulties with their fertility. So with the help of fertility care, we can help people struggling through various reasons with the opportunity to start or expand their family. And I'm sure there are people today who've either been through fertility treatment or definitely know somebody who's been through fertility treatment. So as I said, fertility treatment is very prevalent now. It can be very daunting, it can be very isolating. A fertility treatment it's expensive, it's emotionally taxing, it puts a strain in your life, with all your relationships, your career, your finances, and there's actually no real guarantee of a positive outcome at the end of it. And I've seen firsthand the toll that this can have on our patients that come through our doors. And we here at Care, we want our patients to feel seen, heard, and supported. And we see technology and AI as a way that we can do this, so we can improve patient outcomes and their experiences. So what are some of the considerations that we had when we embarked on our AI journey? So we're innovation leaders. We've always pushed boundaries, and we're harnessing technology in order to benefit our patients in care. We already have great outcomes, and we want to maintain these and attract new patients to our business also. And we've always advanced at a really, really rapid pace. In fertility care, it's a relatively new field, with the first IVF baby only being about 46. So we advanced really quickly, and we want to continue to be world leaders in terms of research and innovation in fertility care. We want to demonstrate our investment in our staff. We want to provide them with the technology so they can improve patient outcomes and work every day on this. It's a really competitive space, fertility care. So we want to demonstrate that we're distinguishing ourselves from our competitors, and we're giving ourselves the edge. So on the balance, we need to ensure that we're creating the right environment to introduce an AI like this. So do we have the skills? Do we have the expertise and the infrastructure to deliver this AI? Do we have the capital investment to drive it forward? Are our staff ready? Are they engaged in technology already? And are they receptive to more technological change? Ethically, would AI be safe? We don't want to cause any harm to our patients or their outcomes. And do we actually have the adequate data to build an AI? So improving patient outcomes, of course, is always central, and it's our main goal when we want to introduce any sort of AI or technology into our practices. However, there are many other improvements that we could make. We could overlook these if patient outcome was our single only focus. So as long as we're not causing any harm or negative outcomes, there are plenty of other potential benefits to harnessing AI. So we could improve patient experience. We could use AI to provide personalized treatment plans, predicting treatment outcomes, such as ovarian reserve and ovarian response. Human error does happen, and AI might make this a little bit safer. And we are human as well, so we're open to subjectivity, we're open to bias, no matter how hard we try. And AI can deliver more consistent, more reproducible results within the clinic as well. So in terms of sustainability, using AI can reduce consumables, although as we know, these processes do lose a lot of electricity at the same time. We can streamline workflows, allowing ourselves to remove repetitive processes within the clinics. So we can move to more kind of nuanced decision making and help AI support us in techniques that have to be carried out by a human. This in turn saves time in our laboratory practices. So through all these channels, we can pass on cost savings to our patients. And cost really is one of the biggest barriers to fertility care. And lower cost treatment models will allow us to attract more patients and us be able to treat more patients, which is really important. So why introduce these technologies now? We have an increased generation of really large data sets, like medical records, genomic data sets, as well as medical imaging data. And improvements in computing power and many other areas of healthcare adapting AI technologies also. So it's seen in mammograms where breast cancer is the detection and the analysis of breast cancer has been revolutionized through AI. So it's no surprise that we really want to do this in reproductive medicine also. AI is great at solving problems, as we know, and it really is good at analyzing images too. So combining this with our sector's desire to constantly improve and the overall increasing of acceptance of AI in society nowadays has allowed for many collaborations where we can use AI and automation to improve patient outcomes and their experiences across healthcare. So there are many potentials of AI in fertility. These systems, they're not intended to replace a clinician, replace an embryologist or a nurse, but rather support our decisions and take more laborious processes out of it. So we can move to a more of a combination of clinical expertise, evidence-based decision-making, and AI tools. And the impact of AI, it's unlikely to be coming from one application alone, but rather the combination of AI applications across all aspects of fertility care. So we can use historic patient data sets to tailor treatment options and make these treatment protocols much more specific to the actual patient and their history. So in the lab, our aim is to get the egg, get the sperm, and mix them together. And hopefully, after a couple of days of growing them in the lab, we'll get a lovely embryo like this. So AI has been used in imaging of eggs and sperm already. So that might give us an idea of the potential of the embryo going forward. However, the embryo still remains the central area of most AI technologies. And as selecting the embryo with the greatest potential of having a pregnancy or a baby really is the pivotal decision in IVF treatment. So this really was our focus at Care Fertility. So getting a bit more technical, in the lab, the routine way that we look at embryos and we see how they're getting on and how they're developing, and we're deciding which one has more potential, which one doesn't. Routinely, we would have an incubator, we take the embryos out, we put them under the microscope, we have a look at them, see how they're getting on. However, we don't like moving embryos, we want to keep them in their incubators, and as we're looking at them over maybe 5 or 6 days of them growing, we're only going to take them out maybe 4 times. So this is giving us really, really small snippets of information, and it's not equipping us with the information to make the best decisions for our patients. On the other hand, morphokinetics, it's more the dynamic observation of the changing embryo over time. So it's a video. As you can see, one very lovely embryo is growing here. So time-lapse technology provides much more information on embryo development. So the embryologist can have a look, can see how the embryo is developing without disturbing the culture conditions, which is really important because they're set to a really particular area. And how we're getting these images is that the embryos are placed in the incubator, but there's actually a camera inside of it. So it takes an image every 10 minutes. And over 5,000 images are actually generated from one embryo as it grows in the lab over 5 days. We can make these key decisions if they're good or they're bad, and it helps to support the decisions that we make in the lab every single day. So in Care, we've been early adopters of this time-lapse technology, and we've been using it for over 10 years. Time-lapse technology provides a lot of insights that we can apply to research and development, and AI is no different. So we can use the static images as well as the time-lapse image sequence in order to build a tool such as an AI for embryo selection. So as I said, morphology is the routine way of assessing embryos. So if this was a patient in our lab and they had to choose between these 2 embryos that we're going to put back, with my embryology hat on, I'm transferring the one on the right. It's a prettier embryo, it looks nicer. Don't be worried if you don't see any difference between these 2 images. So we go through a lot of training, we go through a lot of competency assessment in order to look at the structures within these embryos. However, so if we're choosing between these 2 embryos, we're choosing one of them, it's a little bit more obvious, and we can make a quicker decision in the lab. However, these 4 embryos, they're actually graded really similarly. So it's much harder for us to decide what embryo is the best, which one can we choose to put back to give the highest chances of success. And that's where we can turn to technology and our time-lapse imaging. So as well, if a patient has these 4 embryos and we put them through 2-3 negative cycles, it can put such a strain on them. And they actually might drop out of treatment before they get to the point where they're pregnant and they have a baby, which is a real shame. So what solution did we come up with? So over the 10 years of using time-lapse technology in care, what we were doing was manually assessing each embryo, and we were telling the software when the embryo was becoming 2 cells, 3 cells, when it was compacting. So we're sitting down and we're going through all this. So it's really laborious, and we do it daily in the lab. So for an experienced embryologist, it probably takes about 2 minutes per embryo. On average, a patient might have 10 embryos, so that's 20 minutes spent per patient going through their embryos. And we have a lot more things going on in the lab, so if we can remove these repetitive tasks, then it'd be fantastic. So we developed CareMaps AI, and all this manual annotation didn't go to waste. So what we were doing was feeding into this huge data set. And it's brilliant because across all our clinics in care, we're working under the same laboratory processes and the same protocols. So this is a really, really consistent data set. So we worked with BGSS and then now part of CGI on this project. And what we wanted them to create for us was a tool. So can you tell us, using AI, which of these embryos has the potential to make a live birth? So we wanted to want all the embryos that went on to become a baby and all the embryos that didn't. So we gave BGSS this huge data set of over 63,000 embryos. This was over nearly 500 million images, which certainly had its challenges. But they were super to work with. And those who don't know, BGSS are a global technology and software engineering consultancy. They were brilliant to work with. They got up to speed with embryo development and science really, really quickly. And we worked with them closely over 18 months on this exciting project. So as I said, we shared imaging of 63,000 embryos, and 2 models were trained, validated, and tested. And what we concentrated on was 17 key areas of embryo development and the timestamps that these happened. So the output of this was that we're now automating our annotations. We weren't sitting down at a computer pressing 2 cells to 4 cells to 4 to 3 cells, so it really was beneficial in our lab. So we had auto annotations. It was a really simple user interface to work with, and what we were doing was ranking an embryo from 1 to 10. So the embryo, an embryo was with a CareMaps score 10 out of 10, that had a better chance of implanting and becoming a live birth. So this is actually in use in all our care clinics across the UK and Ireland, and I use it every day in work in Beacon Care Fertility in Dublin. And it really is super easy to use. And because us as embryologists, we've annotated for years and years, and we've fed into this data set. So it's really trusted in our lab, and we really see the time savings and the benefits that it provides. And anything that improves our everyday life and also improves patient outcomes and experience is a plus. So as I said, it's been a real success, this automated embryo selection tool. And just for context, in a lifetime as an embryologist, we might see maybe 10,000 embryos. give or take. And this tool has been built using 63,000, so really, really robust. And we tested it against the best commercial AI embryo selection tools out there, and it was as good as the industry's best. Let's mind the additional benefits of increased accuracy, more consistency across the embryologists in our lab, across all the embryologists in Care, and also the time savings for the lab. So it's been in the lab now for over a year. It's been working really, really well for our patients. And as I said, it's on all the clinics across the UK and Ireland, and we're hoping to implement it into our international clinics soon. So far, over 2,000 AI embryos have been assessed. That were assessed have been transferred back to our patients. We have 800 ongoing pregnancies. What's really great is that we have over 550 babies born so far. This number continues to rise, of course. The tool not only helps us support the embryologist decision-making in the lab, but makes it a little bit more transparent for our patients. So they know a little bit more about the likelihood of their embryos that they have in storage and how likely they are to go on to become a baby, which then informs them on their kind of future treatment as well. So in a year, our CareMaps AI has assessed over 12,000 embryos, which is huge. And it does need our input sometimes if it's not confident, but this happens really, really rarely. And it's been a huge saving for staff time. To quantify this, it's about 400 hours or 53 working days in the year by removing the really laborious manual annotation process. And staff feedback has been really positive, including our own. I'm not sure I could imagine going back to manual annotation after this, so I think I'll be staying with Care for a while now. It releases us so we can concentrate on more kind of nuanced decision making, talking to patients, informing them of how they're getting on, as well as research and development that will further care fertility. We've had great success with this AI tool. Our Chief Scientific Officer, Prof. Alison Campbell, she's showcased this amazing technology across lots of conferences in both Europe and the US. We've consolidated our reputation as real leaders in innovation in reproductive medicine. We've won a lot of awards along the way. And of course, being in an AWS case study has brought us to this really great event today. So it's been an amazing journey, and we should definitely thank our partners, BJSS and AWS, for collaborating with us and making this world-class AI solution possible. So at Care, we really believe that AI should enhance our experts' ability to do their job effectively. And AI provides greater insights to assist with decision-making and making more accurate decisions about a patient's treatment and about their chance of success. However, there should always be a human in the loop. I think my job is safe for another while. But we can move on to making more critical decisions. We can remove repetitive tasks within the lab. The regulation needs to be reactive to AI and automation to maintain safety and effectiveness. Improving our workflow and making each step safer and faster allows more patients to be treated. So it removes a barrier of access to care for fertility care, which is really, really important. And we've always been a really rapidly moving field in fertility care, so we welcome technologies all the time. However, right now is a truly exciting time to be an embryologist. And I can really see how AI and automation is tackling patients' chances. It's allowing patients to have higher chances of success and lowering the amount of treatment cycles that they have to go through. So thank you so much for your attention.
So, Sarah, thank you so much on behalf of the room for coming and joining us here today.
Thank you.
To tell us a bit more about how Care Fertility is embracing AI. We kind of talk and hear a lot about in the healthcare team in AWS about using data to improve patient outcomes, and it's always in the context of saving lives. So it's really enjoyable, sitting and listening to talk about creating life instead. So it's been fabulous, and it is a really emotional topic, as you've discussed. As you well know, not with always successful outcomes, unfortunately. So can you tell us a little bit more maybe about your own personal experiences of how this has helped the patients that you're meeting every day?
Absolutely. So, as I said, our Care Maps AI ranks embryos from 1 to 10. And embryo grading can be a little bit complicated to explain, especially when they're in with us. They're about to have their embryo transferred. There's a lot going on in their heads. So if we tell them that they have an 8 out of a 10 chance, they have a high chance of an implanting, it's more transparent. It's easier for them to understand. We're not throwing as much information at them. And yeah, absolutely, infertility can be really emotional. And I've seen how it can have a massive impact on a patient's life. So when it comes to their career, their family, their finances, I've had patients tell me it's just all encompassing. And anything that we can do to improve their chances, to let them know what their chances are of actually having a baby. Because that's one of the questions we get very commonly. It's what are my chances of having a baby? And if we can make this a little bit easier, if we can put them through less treatment cycles, which take an awful lot of preparation, then that's for the better.
Amazing. And something I was really blown away by was some of the stats that you shared around the amount of time that using this system is actually saving embryologists in the lab. So can you talk us through what does that actually look like in practice on a day-to-day basis? How has your job changed?
Yeah, absolutely. So it really has revolutionized our workday. So one of the first things we do in the morning is looking at how all our embryos are growing. And we were manually putting in how they were growing, what timestamp to put on certain aspects of embryo development. But now that's all taken away, so it takes us an awful lot less time. So before it was 20 minutes per patient, and now we're getting finished up much earlier. So we can get on to calling the patients, letting them know how their embryos are developing, because I know they're waiting on our call every day. There's more hands-on techniques. Our procedures have to be done within really, really strict time limits. So that's us get on to that more kind of important work that a human has to be involved in.
And you joked a little bit during your presentation about your job being safe for now, and it's a huge narrative we're hearing at the moment around AI taking, replacing humans and taking jobs. Like, how do you feel around that narrative? As someone yourself, you're working in the lab.
Yeah. Well, I do think my job is safe for now. So fertility care is really emotional, and there's a lot of human connection involved in it. So I can't see it being completely automated anytime soon. It's really important that there's a human there keeping a patient going while they're going through this difficult journey. And although we will have more automation, and I do welcome more automation in the lab, more AI, but it's not going to replace us completely.
It's more kind of augmenting.
So it's helping us in the lab. So it's almost like having another staff member, more boots on the ground, helping us get through our day and all the procedures that we need to do.
Okay, great. And how long did this project take from beginning when BJSS were approached with this challenge? How long did it take to go from that ideation phase to proof of concept and into production in the labs?
So as I said, we had this large data set, and we approached BJSS that we wanted to make an AI tool to predict live births. So I think it was about 2021 that we approached them. So we worked really closely with them for about 18 months. And this went live clinically then in early 2023. So they worked really, really well. And it's a real testament to them how much we like using this in the lab. It's a testament to BJSS, it's a testament to AWS for building such a fantastic AI tool that makes our lives in the lab easier. It's able to actually facilitate the analysis of 800 embryos simultaneously across the care network.
Wow.
And we get the results. So what our embryo is ranked 1 to 10, we get it back in about 1 to 2 seconds. So we're a busy lab, and we require our equipment and our technology to keep up with this, and it definitely does.
Wow, that's fascinating. It's amazing, and it's an amazing journey that you've been on. From 10 years ago when the time lapse technology was introduced, and then 10 years later you're taking this massive data set, to build a model. To be able to analyze and say, which of these embryos is going to be the most successful. So I'm kind of wondering, what's next? Where is the future of fertility treatment going?
Yeah, absolutely. So I think definitely more AI, more technology, and we have teams here in Care. They're looking at what's next, what's out there, what can we do, and we're continuously driving, and we're at the forefront of this. So embryo selection is one aspect of fertility treatment. It's a really important one, but it is only one. So there's all areas of personalized medicine that we can involve AI in, such as drug dosages. We can use it for ultrasound imaging. So it's really about personalizing a patient's treatment. And honing in on their specific circumstances, their history, and providing them with the best outcomes. And I'd say the best is yet to come.
That's brilliant. That's all we have time for. So listen, thank you so much, Sarah, again, for joining us today. It's been a fascinating journey to learn more about, and ultimately about improving the lives of people that are trying to conceive and reducing that, the physical, emotional, and financial toll even as well. So listen, thank you so much. It's been inspiring to hear about it.
A big round of applause for Sarah and Neve. Thank you very much, ladies.